The next class of compounds of alkali metals we are going to discuss are carbonates. The general formula for carbonates of alkali metals is M2CO3. This is the general formula for the carbonates of alkali metals. For example, you have Li2CO3, Na2CO3, K2CO3 and so on. Carbonates are thermally stable. This is the most important feature of carbonates of alkali metals. Carbonates of alkali metals are thermally stable. That means when you heat them, they don't decompose, they actually melt before they decompose. Whereas all other metal carbonates in the periodic table, you take any metal carbonate, say calcium carbonate, zinc carbonate, these carbonates on heating decompose to give metal oxide and carbon dioxide. So there are four thermally stable carbonates. There are four thermally stable metal carbonates existing, that is sodium carbonate, potassium carbonate, rubidium and cesium carbonate. Here within alkali metal carbonates, exception is lithium carbonate. Lithium carbonate decomposes on heating. If you heat Li2CO3, it decomposes to give Li2O and CO2. This is thermally unstable, it decomposes on heating. The reason is small size of lithium. It is too small to handle a large anion carbonate. Carbonate is too large and lithium is very small. That makes lithium carbonate thermally unstable, and on heating it decomposes to give lithium oxide and carbon dioxide. Whereas the remaining four alkali metal carbonates, sodium carbonate, potassium carbonate, rubidium carbonate and cesium carbonate, are thermally stable. That means when you heat, they melt before they decompose. All other metal carbonates in the periodic table, they decompose on heating. Another important feature is aqueous solutions are alkaline. Aqueous solutions of alkali metal carbonates are alkaline. That is because of hydrolysis of carbonate, and when in solution hydrolyzes to give OH minus ions. This makes the solution alkaline. They give pink color with phenolphthalein. Phenolphthalein is an acid-base indicator. So if you put a drop of phenolphthalein in a solution of alkali metal carbonate, it gives a pink coloration, indicating that the solution is alkaline and it has a pH above 11. That's about carbonates of alkali metals. So two important points regarding these substances. Number one is they are thermally stable, they do not decompose on heating. Another important point is their aqueous solutions are alkaline due to hydrolysis of carbonate. Among alkali metal carbonates, there is only one exception, lithium carbonate, which decomposes on heating. This particular feature is unique for alkali metal carbonates. They are thermally stable. That's all for the time being regarding carbonates. Now let's learn about bicarbonates of alkali metals. The general formula of bicarbonates of alkali metals is MHCO3. MHCO3. Now let's learn about bicarbonates of alkali metals. Most important thing is LiHCO3 does not exist as solid. That means it is not possible to have solid lithium bicarbonate. Lithium bicarbonate can exist in aqueous solution, but it cannot exist as a solid. You cannot expect lithium bicarbonate to exist as a solid. All other alkali metal carbonates, bicarbonates can exist as solids. Sodium bicarbonate, potassium bicarbonate, rubidium and cesium bicarbonates can exist as solids. Actually, this is a unique feature of alkali metals, that their bicarbonates can exist as solids. No other metal bicarbonate can exist as a solid. See, you cannot have calcium bicarbonate existing as a solid. Zinc bicarbonate cannot exist as a solid. Only four metal bicarbonates exist as solids. These are alkali metal bicarbonates. Others exist as solids. Others means NaHCO3, KHCO3, RbHCO3 and CsHCO3. These substances only exist as solids. So, there are only 4 solid metal bicarbonates. This is the list of the 4 solid metal bicarbonates. All other metal bicarbonates in the periodic table, they exist only in aqueous solution. They do not exist as solids. Another important feature is aqueous solutions are alkaline. Aqueous solutions of alkali metal bicarbonates are also alkaline, but there is a point of difference you need to know is that carbonates are more basic, more alkaline, their pH is higher than the pH of bicarbonates. Remember that the pH of alkali metal carbonates is somewhere beyond 11, whereas the pH of alkali metal bicarbonates is somewhere below 9. So, these solutions do not turn phenolphthalein pink. They do not give pink color with phenolphthalein, whereas alkali metal carbonates give pink color. So, phenolphthalein is an indicator of choice to distinguish between alkali metal carbonates and alkali metal bicarbonates. That is all regarding bicarbonates of alkali metals. Let us learn about nitrates of alkali metals. The general representation of alkali metal nitrate is like this: MnO3. This is the general formula for an alkali metal nitrate. Now, remember that when an alkali metal nitrate is heated, you get this and oxygen gas. This is nitrite. This is nitrate. While nitrates are salts of nitric acid, nitrites are salts of nitrous acid. This is a salt of nitric acid and this is a salt of nitrous acid. So, when an alkali metal nitrate is decomposed, is heated, it thermally decomposes to give metal nitrite and oxygen gas is produced. And the exception is again lithium compound, that is lithium nitrate. If this compound is heated, it gives Li2O, NO2 and O2. Look at the difference. The other 4 alkali metal nitrates decompose in this manner. This type of decomposition is undergone by sodium nitrate, potassium nitrate, rubidium and cesium nitrate, whereas the type of decomposition undergone by lithium nitrate is different. It decomposes to give metal oxide, that is lithium oxide, NO2 gas and O2 gas, 2 gases. This is reddish brown, and you know very well oxygen is a colorless gas. Remember that both are paramagnetic gases, while one is colored reddish brown gas, the other one is colorless gas. This type of decomposition is possible in case of all other metal nitrates in the periodic table, all other metal nitrates. So, there is a unique feature of alkali metal nitrates, that too 4 alkali metal nitrates, they decompose to give nitrite. All other metal nitrates in the periodic table, they decompose to give NO2 and O2 gas. Take the case of calcium nitrate, for example. Calcium nitrate on heating gives calcium oxide, NO2 and O2. Same is the case with zinc nitrate. Zinc nitrate decomposes to give zinc oxide, NO2 and O2. You take any metal nitrate in the periodic table, it decomposes in the same manner. It produces 2 gases, NO2 and O2, whereas alkali metal nitrates, they decompose in a different manner. They give alkali metal nitrite and oxygen. This is how they decompose. That's all about alkali metal nitrates. Please remember this feature, that lithium nitrate is different from the other alkali metal nitrates in the manner in which it decomposes on heating. It gives metal oxide, NO2 and O2, like all other metals in the periodic table. Sulfates of alkali metals. The general representation of sulfates of alkali metals is M2SO4. Here I would like to talk about thermal stability. These are thermally stable substances, again the exception is same, Li2SO4. This on heating decomposes to give lithium oxide and sulfur dioxide along with oxygen. Like for example, if you heat Li2SO4, you end up with this substance Li2O, SO2 and O2. Others are thermally stable, and the thermal stability increases as you go down the group. The reason is sulfate is a large anion and it requires a large cation to stabilize. Now, one important feature regarding this is Li2SO4 does not form alums. All other alkali metal sulfates can form alums. Lithium sulfate does not form alums. The reason is the size of lithium is too small to form an alum. What is alum? Why lithium does not form alum? A clarity will be given under third group, that is boron family, not now. Just keep in mind that lithium sulfate does not form a particular class of compounds called alums. Alums are double sulfates, and detail about alums will be discussed under boron family. That's all regarding sulfates of alkali metals. Alkali metal sulfates have general formula M2SO4. They are thermally stable except lithium sulfate. Lithium sulfate on heating decomposes to give lithium oxide, sulfur dioxide and oxygen gases.